chemistry class. Today's topic is chemical equation, and this is lesson 2. In the previous lesson, we discussed on the concepts of chemical equation, chemical reactions, and the characteristics of chemical reactions. In today's lesson, we are going to concentrate on writing and balancing chemical equations. Writing and balancing chemical equations. Welcome. In writing and balancing chemical equation, any chemical equation or any chemical equation must be written by using the law of conservation of matter. By using the law of conservation of matter, which states that in any chemical reaction, the total mass of reactant must be equal to the total mass of product. The total mass of reactant must be equal to the total mass of product. If we have reacting particles, then the total mass of those reacting particles or chemicals must be equal to the total mass of the products formed. Must be equal to the total mass of the products. Now let's see the steps following writing chemical equation. The first step, you can be more clear if you start writing your equation by using a word equation. This simply means you write the equation in word form. You write equation in word form. Let's see 2 examples here. We have the first one, reaction of oxygen and hydrogen to produce water. Let's say you react oxygen and hydrogen to produce water, and you have to write the chemical equation for this reaction. As in this first step of word equation means you write the name of those reacting chemicals or reacting substances, like you can see here. You write oxygen reacting with hydrogen to produce water. So this is the word equation. You use the chemical names of the reacting particles, like oxygen reacts with hydrogen to form water molecules. Or we see the second example here, that decomposition of lead carbonate to give lead oxide and carbon dioxide gas. Here is like we have lead carbonate. Lead carbonate, this is a large complex compound. During decomposition, it breaks down into its smaller components or into its either smaller components or individual elements. Let's see what happens in case of lead carbonate. In lead carbonate, it decomposes or it breaks down into lead oxide, and the other product is carbon dioxide gas. So from here you can see the first step. To be clear, you have to write the equation by using the chemical names of the substances. That's the first step. Second step, now let's see the second step, which is a symbolic equation. Here we include all the chemical symbols and formulas of the reacting elements or reacting compounds or decomposing substances, depends on the reaction. Let's see, we take the first examples, like when reacting hydrogen and oxygen to form water. Now we write the chemical symbols of those elements, like all those molecules, all those compounds. We write hydrogen gas reacts with oxygen gas to form water molecule. And in writing this, just make sure that all the symbols and all the formulas are correct. The other thing, you can write the composition reaction of lead carbonate, that this on heating it can decompose, and it decomposes to form lead oxide and carbon dioxide gas. So you just write the symbols of elements and formulas of those compounds. That's the second step. The other step then, we have to make sure this number of atoms of elements in each side, I mean in the side of reaction and in the side of reactants and in the side of products are well balanced. Then let's see here. We have from the first example that hydrogen gas combines with oxygen gas to form water molecule. You can see in balancing here, like we have 2 hydrogen atoms, 2 oxygen atoms. In the reactor side, we have 2 hydrogen atoms and 1 hydrogen atom in the productive side. So we have to balance. We have to balance the question. It's like we can balance the number of oxygen. We have 2, so we place 2 here. And we have 4 hydrogen atoms, then we place 2 here as well. So this is just the balanced chemical equation of the reaction between hydrogen and oxygen to liberate water molecule. Let's see another example apart from these 2 here. Let's say we react nitric acid. Yes, we react nitric acid and one of the bases like sodium hydroxide. Let's see what happens. Nitric acid and let's say sodium hydroxide. In this chemical reaction, you can see we will have sodium nitrate and water molecules as the product. So in the products here, we will have sodium nitrate and the water molecules as product. So we have to make sure that the number of atoms of compounds that are reacting is exactly equal to the number of atoms of products that are formed. As you can see, we have 2 hydrogen atoms. We have 2 hydrogen atoms in the product side. We have 4 oxygen and we have 4 oxygen. 1 sodium, 1 sodium. So it's all about balancing. Making sure in the reactant side, the number of atoms are equal to the number of atoms of all the elements in the productive side. Apart from just balancing, we have to indicate state symbols. We have to indicate state symbols. It's like, in case of indicating state symbols, we indicate whether the reacting particles are in either solid state, liquid state, gaseous state, or are in aqueous form. Aqueous form means they are in aqueous solution, or they can form solution in water. They can dissolve in water simply. You can say that way. Let's indicate state symbols for the reaction between hydrogen and oxygen. We have let's take this as an example. Hydrogen gas, this is a gas. So we write small letter G right here. Small letter G here indicating that this is oxygen gas. And water is simply a liquid. So the last step is all about writing or indicating the state symbols of elements. We have 4 steps. Write word equation, write symbolic equation, balance the equation, include the state symbols. And by concluding then, let's see significance of doing all this. Why balancing chemical equation and what is the advantage of it? Let's see significances. We have two of them here. The first one is a balanced chemical equation shows the actual number of atoms and molecules that has been participated in the chemical reaction. So they show the actual number of atoms that takes place during the chemical reaction, that participates in the chemical reaction. We can also see another advantage or significance here, that it summarizes what takes place during the chemical reaction. It summarizes. Instead of writing all the processes that these reactants reacted with other reactants to form certain products, we can summarize all the process by writing a very simple chemical reaction. It's like we can represent maybe nitrogen gas combines with hydrogen gas to form ammonia gas. So we can summarize what takes place. It's like you will see that 2 nitrogen atoms would react with 3 hydrogen atoms to liberate 2 molecules of ammonia. To liberate 2 molecules of ammonia gas. And all these are in gaseous form. So it summarizes a presentation of what takes place during the chemical reaction. Today's lesson was all about writing and balancing chemical equation and the significance of writing and balancing chemical equation. Thank you for watching. Keep on watching more lessons through this TanzaEdu platform, as this is a right channel for nurturing your destiny. Please remember to like, comment and share, but please do not forget to subscribe for more lessons. Welcome.